Hello, ladies and gentlemen. Day 2. We're going to finish the idea of naming and a couple little characteristics for ionic compounds, and we'll move right into the covalent compounds. This will be quite a bit shorter than yesterday. Here's a new thing for you called hydrates. In nature, ionic compounds can be attached to a whole bunch of waters. Obviously, water is all around us, so water has the ability to attach itself to a couple ionic compounds. To name hydrates, you just simply have to state how many waters are attached to the ionic compound, and we use the prefixes for those. It's the same prefixes you're going to use for the covalent compounds. We may as well do these now. Mono, di, tri, tetra, penta, hexa, hepta, octa, migramma, and deca, which is 10. So to name these things is very, very simple. If you have CuBr2, you look up those element names. It's copper. Br is bromide. When you look up copper, you're going to notice that it has multiple options for its charge, so you have to use Roman numerals. So this is going to be copper 2, because bromine is a -1, and there's 2 of them, and the copper has to balance off. So it's copper 2 bromide. Then you just got to state how many waters are there. Well, there's 2 waters, so it's dihydrate. That's it. It's exactly like yesterday. But now you just throw monohydrate, dihydrate, pentahydrate, just however how many waters molecules there are. FeCl3, that's iron. Cl is chloride. You're going to notice that that iron has multiple charges. In this case, iron is going to be 3, iron 3 chloride, and there are 6 waters. 6 is hexahydrate. There you go. And if you're going backwards, you're given all this, and you just put 6 waters if it says hexahydrate, or tetrahydrate would be 4 waters. Nothing fancy. Naming acids, we keep things pretty simple in Chem 11 this year. There's just a few acids that you're going to see pop up. There's some patterns in the naming, which is why I have your notes set up like this, but let me quickly show you what they are. First off, all acids have an H out in front, except for a couple different types, but we're not going to get too fancy this year. We're going to just recognize one acid that has an H at the end, and you'll see it down here. So HCl, these are all your halogens. They all start with hydro, and then that's chlorine, but because it's an acid, it's going to end in ic, so it's hydrochloric acid. HBr is hydrobromic acid. HF, probably getting the pattern here, is hydrofluoric. Obviously it ends in acid. And HI is hydroiodic acid. A couple other acids that are pretty common are ones that contain nitrogen. This is a nitrate ion. Nitrates, those get changed to ic. So HNO3 would be nitric acid. NO2 is nitrite. They get changed to an OUS. So this is nitrous acid. That's sulfate, just like nitrate, so this gets changed to an ic, so this is sulfuric. And sulfite gets changed to sulfurous. And phosphate gets changed to phosphoric. There's a real pattern there. This goes to phosphoric. Phosphoric acid. And last but not least, this beginning part right here is called acetic. Or acetate, actually. So acetate, you're going to change that to an ic, like all the other ones. So this is acetic. And we'll go over more detail about why that's an acid in class tomorrow. The last type of thing we're going to name in Chapter 4 are the covalent compounds. Again, we're going to be calling them molecular compounds, but we can call them covalent compounds because they do have covalent bonds. Naming and writing the formulas are a little bit different than for ionic, simply because they contain 2 nonmetals. They have different bonding properties. We don't need the charges, and this time I'm not lying. And there's the prefix system that we did yesterday, the mono, di, tri, tetra, that tells you how many elements there are. So if you're given the name dinitrogen, that tells you there's 2 N's. So you write N2. Tetraoxide is 4 oxygens, so you write O4. So dinitrogen tetraoxide is simply N2O4. Pentabromine, Br is bromine, 5. Mononitrate, NO3, that's nitrate, and mono means 1. So Br5NO3. I have no idea if that's a real thing. Hopefully no one with a real big chem background is going to mock me for this, but there it is. P2O3, it says there's 2 P's, so P is phosphorus, so it's diphosphorus. O3 is trioxide. We'll try those other 2 in class tomorrow. Other than that, ladies and gentlemen, we're going to tweak a few details in class, play a few games. We're going to have a short little quiz on naming ionic, and we'll do a short little quiz on naming covalent the next day. See you in class tomorrow.